Welcome back to this chapter, and today we will talk about job and instances. In Prometheus term, an endpoint you can scrap is called an instances, usually corresponding to a single process. A collection of instances with the same purpose, a process replicate scalability or reliability. For an example is called job. Let's take an example. The configured job name that the target belongs to. An instance is host port number, the part of target URL that are scrapped. Take an example in the Prometheus configuration file, what we have written here, job name and then target. Here the job name is called node exporter. It means that node exporter service that we want to install on many servers, right? And the target here we specify the second worker node 1, right? Second instance. So this is called instances. And this is also a instance. So instance always with come up with IP address plus port number. However, the job name should be a common for many things, for many purposes. This is what it is says. Endpoint you can scrap is called an instances. In short, we can say that the end client name is called job. That's it. This is the basic difference between job and instances. Today we are going to cover the theory part. For that reason, I'm just explaining all these stuffs. Let's talk about metrics and labels. Every matrix in Prometheus has a name. That name is called metric name. Simple. Metric name is specific to an application. The prefix is usually the application name itself. Take an example node exporter. So we start all the metrics start with node underscore something like that. I will show you. Don't worry. Sometimes, however, metrics are more generic, like standardized metric exported by a client library. Example Prometheus underscore notification underscore total specific to Prometheus server. Prometheus collect various metrics such as CPU, uses, memory, network, traffic, application specific metrics. These metrics can be used to gain insight into the performance and health of system and application. Right? So let's talk about metrics type. Prometheus support different metrics type, including counter, cumulative values, gauge, instantaneous value, histogram, value distribution, and summaries, quantile based value distribution. I will explain you in my coming slide, don't worry. So let's talk about counter metrics. So what are counter metrics? Counter metrics are the type of metrics that represent a cumulative value. That value can increase over the time or restart the value to zero. Counter only count upward, not go downward. They are usually used to track the number of events such as HTTP request, error, database queries. What would be the use cases to understand better? From the graph you can see here that one can notice that it is going straight or upward. It's not going down or up. Okay. So use cases are counters are useful for monitoring the growth of value over time, such as total number of requests processed by an application or the number of error encountered in a system. Example, the number of successful HTTP requests handled by a web server is a common example of counter. Executing the command ifconfig, you will observe the error message increase over the time. It is never go down. Most of you all already know that in Linux operating system when we there is some error, so we always try to run ifconfig and see if the error is increasing or not. Right? It's never go down. We can reset. So this is called counter. We can reset the counter, but it never go down. Take an example here in the Prometheus. If I select node underscore, so these are the metrics name and here these are the type. As you can see here, counter, counter. So these are node underscore CPU underscore guest underscore second underscore total. So this is for total total. It is always a counter type matrix. Let's talk about the second type of matrix, that is gauge. Gauge are the type of matrix that represent the value that can increase or decrease over the time. They are used to measure the current state of system, such as the amount of memory used. Maybe this time it is high and after 1 hour or if we kill the process it reduced, right? The number of active connection or the temperature of the server, it may increase or decrease, right? So for that reason we are using gauge type of matrix. Gauge will count upward or downward. So that's a basic difference between gauge and counter matrix. I hope it is clear now. So let's talk about the use case. And here in the graph, use cases, gauge are useful for monitoring the current state of system, such as availability, capacity of resources, or the current load on a server. It is self-explanatory. I don't think so that anyone needs some more explanation here. Take an example. The current CPU utilization of a server is common example of gauge matrix. It's fair enough. Histogram matrix. Now what is this histogram? We have different type of needs, so for that reason Prometheus come up with different type of matrix. Histogram are the type of metric that measure the distribution of a value over time. This is what you need to take care of that. They are used to track the frequency and duration of event, such as response time of API server or duration of database query. Take an example. If we send any request or if we use any API server that fetch the data or it upload the query on the web server, how much time it takes when we send the request. Sometimes it takes 3 seconds, sometimes it take 1 second. So we need to measure how much time it take total. For that reason we use histogram metrics. Okay. A histogram count the number of observation or event that fall in a set of configuration in a bucket. Or you can say that we can create a rule in that what it's fall we get the value. Each bucket separated by a time series. In this period of time it take this much of time. A histogram use a label to differentiate between the buckets. Let's take an example of the use case. Histogram are useful for understanding the performance characteristic of system, such as the latency of request or the duration of database query. Sometimes we want to write something on the database or we want to fetch something from the database. So how much time it takes? Let's take an example with the time series here. The response time of HTTP request is common example, right? We can say that HTTP request code during the bucket 0.2 second, how much time it takes. Maybe it take 1000 queries are fall into 0.2. It means that our database server is working fine. Or if it lies on the bucket of 0.5 second, less than 1 minute or greater than 5 minute or 5 second. Take an example. So these from these values we can get to know that our database server is working fine or our API server fetching the data from the client machine, it is working fine or not. From these, with the help of this histogram we can get it, right? Sometime why we are learning this thing, let me tell you that sometime we need to create the matrix by ourselves. Okay, for that reason we should know the type of matrix, what matrix we need to create here. Summary matrix. Summary metrics are the type of metrics that provide statistical information about a set of value, such as the sum, count, minimum, maximum, and quantile. It is like a histogram matrix, but it exposed matrix in the form of quantile instead of bucket. In layman language, we can say that how much percentage it took 0.5 second, how much percentage of queries fall inside that bucket. Sometimes we want to know the percentage value, right? Whenever we need a percentage value we always use summary matrix. Use case summary metrics are useful for understanding the distribution of value such as latency of request or size of response. Same as it is just as a percentage. For an example, the latency of HTTP request with calculated quantile. Quantile means percentage. Is common example for the summary metrics. That's it. And how label works here. Example, node underscore CPU underscore second underscore total CPU equal to 0. Sometime, not sometime, it's often whenever we are working on Linux type operating system or we are working for servers, we have more CPU, right? Sometimes we have 16 processor running, sometimes 32 processor running. So it stand where CPU equal to 0 and CPU equal to 1. So this 1 is labels. Let me show you here. This CPU equal to 0, we can find of 1. If we want to check the performance, we can use, this is my matrix name and this is for labels, or we can say that sub labels if we want some more information here. So this is my instance. From the this output we can say that this is my matrix name, this is my label, this is my instance, this is the client machine IP address, and these are job and mode. So these are sub labels. Okay, so now you can understand that the difference between metrics, labels, instances and sub labels. So how labels work? Unique identification. Labels give us unique identification. Take an example of labels allow Prometheus to uniquely identify each time series data point, enabling efficient storage and retrieval. Take an example, we have 16 processor are running on our operating system and one of the processor are not working good. So how we can check? With the help of labels. Second thing is filtering and querying. User can filter and query metrics using the label selector. As I said that, okay, take an example, one of the processor is not working fine, so we can say that CPU equal to 10, give me the metrics of value of this. If it's taking too much time or if it's always 0, it means that this processor is not working or not working expected. So we can filter out with the help of labels. So this is the useful of labels. Filter data with labels in PromQL. We have seen that Prometheus data have labels, allowing us to filter the metrics we have stored. Here's our overview of the label matching operating system. We can say that equal to select the label data exactly equal to providing string. Exclamation sign equal to, it means that select the label data not equal to providing string. We can also filter the labels with the help of these filter. Select the label that are regular expression match the providing string. Regular expression we can also use in the PromQL query. That's great. Exclamation sign and then this, it is do not regular expression match. That's it. We can use here, as one can see, it has used the regular expression and it is equivalent to this. When we use code equal to or CPU equal to whatever, we can categorize how we can select the data what we want. So all these features Prometheus offer us. So that's a good thing. So this is the reason Prometheus is in boom in the market and everyone is want to install the Prometheus and want to learn how Prometheus work. So these are the flexibility it provides. So now we understand the filtering and querying. Take an example of other aggregation. Labels enable powerful aggregation function in Prometheus, allowing user to calculate summary, average and other statistical insight on that. And the last one is alerting. It is also used for alerting. Labels are essential for defining alerting rules in Prometheus, helping to identifying and respond to critical issues. With the help of labels, we can use manywhere. and we will explore slowly. Don't gradually we will explore everything. Don't worry. Okay. We are just go not too deep, but we are just checking what are labels and how we can use these labels. Here are the example of Prometheus labels. Labels like service equal to web or service equal to database we can use. It help organize metrics by a specific service that they belongs to. With the help of this, we can check, or we can use labels like environment equal to production or environment equal to staging. It allow for easy monitoring for different environment. So it's all up to us how we define the labels, and after that we can use those labels. Labels like instance equal to web 01, if we have different type of servers web 01 or web database 02, we can also check. So it uniquely identifying individual instances of a services. So it's all up to us how we can use these labels. So it is for service, this is for environment, and this is for instances. So let's check with lab for metrics and labels. It won't take more time, I believe so. Now I have opened my Prometheus server. Let me remove all these stuff here. And here graphs, I'm in graph. And if I select the query, let's take an example for memory, node memory matrix byte. If I execute here, it gives me this value. Now we can see that this is my matrix name. This is my instance. It fetched the data from 1.32 server, and after that job equal to node exporter. So this is my job here. This is how I can check. And if I check for the CPU utilization, this is for my matrix type. Now here all these values are representing to different. So this is my matrix name. This is my labels 0 to CPU 0. Okay. And here it is 0, sorry, CPU 1. And these are my instances, and these are my jobs name. And inside mode, ideal mode, input output wait, IRQ, nice, soft IRQ, steel, system, user, ideal, input output wait. So all these information it fetch from the operating system, and with the help of node exporter. When we install the node exporter, all these metrics are inbuilt when we install the binary of node exporter. And if I come here and if I remove node, these are the different type of metrics, right? Counter, gauge. We can create gauge, histogram, and summary also. Don't worry. These are the type of metrics that we want to, if we want this information. Okay, and gauge histogram I have already shared with you, and labels I have already shown you here. These are the labels, mode equal to this one, and this is CPU equal to 0, and this is my sub labels. This is my first label. This is my sub labels. These are the basic one. If you have any question, please write the question in the comment section. I will try to answer you. If you like this video, I try to explain in a very layman language so that you can understand. I'm also not the part of monitoring team. I'm also part of DevOps operation team. But here I learned only for you so that I can share my experience with you. If you need more information, do comment me. In this topic, we will talk about query and function. Query Prometheus. Prometheus offer a function query language called PromQL. Prometheus query language that help us or maybe user to select and aggregate time series data in real time. What it means, let's understand. The result of an expression can either be shown as a graph, viewed as a tabular data in Prometheus expression browser that we shown in previous, or consumed by external system via HTTP API. As we know that Prometheus expose a database through HTTP, right? So we can use HTTP. Let's move forward. Example. Prometheus HTTP request total. If we execute this command, or maybe we can execute Prometheus HTTP and then handler, whatever the handler it is, I will show you in a couple of minutes. When we execute this, it means that this is my matrix name and this is my matrix name again. And here we are adding labels, right? Or we can also use 5 minute. I will show you in the graph here. It would be easy if I can show you here. If I execute this command, Prometheus matrix, this is the matrix name. It shows me couple of results here, right? And if I execute here, this is my 13 here. So handler, other thing, paste it over here. If I execute, I see 136 and 15. This is my 200 code and this is my 400 code. But here I select the labels handler equal to API v1 query. So against this matrix, I have 136 result. Now I can also use, or maybe if I click here graph, I can see a good way here. I can increase the time or decrease the time here. Let me, now you can see here it's a time here and here it says the number of requests and here it is the time. If I click here table again, if I copy, I will explain you what is the meaning of 5 minute. Don't worry. Now I can see here from last 5 minutes how many datas are there for this particular label. Okay, now you understand that what is this 5 minute, right? So these query we can execute from the portal itself. In Prometheus, an expression or sub-expression can evaluate on one of four types. Now again these queries having a something. So first is instant vector, a set of time series containing a single sample for each time series, all sharing the same timestamp. If I go back here, this is my single value for this single time series data, right? Now, if I move forward, range vector, the second one is range vector, a set of time series containing a range of data pointing over a time for each time series. What it means, range vector. If I add here bracket 5 h for hour, okay, and if I execute here, I see the ranges of value. It means that for a single matrix, or you can say that a single expression, we have multiple values. So that is called range vector. I hope now it is clear. The first two are the example of instant vector, and the third example is the example of the range vector. Okay. In range vector, we can again sub-classify into different categories. The first one is time series. The second one is offset modifier. Third is only modifier. And the third is scalar, a simple numeric floating point value. I will show you, don't worry. And string, a simple string value currently unused by the Prometheus. But yes, there is an option. In future, you will observe this string. And all these detail you can get it directly from the Prometheus web server. If you go to this URL, okay. Time duration. What is time duration? MS is for millisecond, S for second, M for minute, H for hour. In our case, I used here H is for hour. If I remove here from H to M, I will see from last 5 minutes I have these data. Okay. We can use W for week, Y for year. If I use this command M5 M for minute, right? If I go ahead for one H for hour, and same thing if I go with here one for one D is for date, one day. Now what is offset modifier? In offset modifier, the offset modifier allow changing the time offset for individual instance and range vector in a query. What it says in a simple English says that if I use offset 1 hour, it means that it will show me the data from last 1 hour. Let me show you here, not last 1 hour, but let me show you here. Click on the graph here and remove this M. Now execute this value. But it says how we can use this offset modifier. Just use offset 1h. For now, if I increase this browser here and see, my graph is starting by 12:30. If I use here offset for 1 hour, now here I need to use offset of that 1 hour h, 1h, or I can use directly here like this one. If I execute here, the time is 12:30. If I execute this command here, now I see the value is coming from 130, 1330. It means that it offset the 1 hour. Now I hope it is clear now. Sometime we need to check. I will show you. Give me one moment here. I have already captured. Now let me show you here for the offset. Let's take an example that if we want to know the current memory uses, how we can check current memory uses for the node. We can tabular here, remove this one. Node memory total bytes. This is my total bytes here. If I minus my available memory, then I can get it. Then I can get my uses memory, right? So this is my uses memory right now. Let's say you want to observe if the current memory usage is significantly higher than it was 1 hour ago. So you can use offset value. How we can use this thing? Let me copy and paste it over here. I just add bracket here. Slash is for dividing. And after that same thing, but offset is 1 hour. Same value, but we have mentioned here same expression divided by same expression space offset 1 hour. If I execute here, so this time I'm observing only one difference here. So it is my consumed memory, or you can say that current memory uses if I compare with last 1 hour. Also, we can say that I want to see if it's greater than 1 or 1.5 hour. If I execute this thing, I see nothing here. But if I remove here one, if it's greater than 1, then it says yes, this is the value here. So how we can use here, it's a subtraction and this is for divide and it is greater than 1. So these are the options that we can use, or in future we can say that okay, if this memory is consumed by 80%, then we can also create an alert. I will show you in my next topic video where we will create the alert. Then we will see here if it's greater than 80 or greater than 90, then it should generate the alert for critical alerts. Okay. And same thing, let me show you one thing here. In Prometheus HTTP code here, as of now, we have just installed the Prometheus. So I'm just showing you here. All these are the value here. And if I check the 5 minute, I see all these value. But let's take an example that if I want to check the rate means average of last 5 minutes. What we can do here, we can use one function and that function is called rate. Just add here rate, that's it, and then execute here. Now I can see the average rate of this value. Also we can multiply by 100. These values are not good, so sometime we need to multiply by 100 so that we can see some value. We can also do like this way, or we can also bracket and then we can say that okay, if it's greater than 2, then it shows me the value, or if it's less than 4, it show me the value. It says this, these are the value, less than 4 it is the value. Okay, the same way we can, it's up to us how we want to create the expression, and based upon these expressions we will create the rules when we create the alert manager, right? Now you can understand that all these are the features that are provided by the Prometheus. What is modifier? The modifier allow changes the evaluation time for individual instance and range vector in query. Now in simple word, what we can say here that remove all these stuff here and also remove this rate. Now execute this command here. There is some error messages. Why it is says error? Remove all these stuff here. Now execute. So these are my 5 minutes average, not average, but 5 minutes data. Now I want to check what is the information at this particular time. So what I can write here, if I click here, what is the syntax? We can use at the rate, that's it. Same thing I'm executing here, 5 minute. If I want to, obviously when I need to use only one time, so I don't require this 5 minute here. Add this simple syntax here. That is node memory active bytes job as node exporter and this particular time. What is this? I see this value here. Okay. So we can also check at particular time what was the value of that particular matrix. So let's move here. So here I have already mentioned ancient what is ancient vector. What you can use here range vector. The range vector is set of time series containing the range of data. And here it's a single sample for each time series. What is scalar? We can use rate. This query calculate per second per node. This is 5 minute. This is my scalar. And string, as I said that it is not used as of now. Let's move here. We can also move forward. What is querying Prometheus a powerful tool? The operators, with the help of operator we can enhance our expressions, right? That I show you right now, right? We can use plus or we can use minus. We can also use multiply by 100 if we want to know the value in percentage. Slash divided by we can use percentage is here is exponential. We can use here. It's all up to you how you want to create the rules. Expression is mainly for creating the rules. Besides this, Prometheus provides a powerful query language to allow, explore, and analyze your time series data. You can also use various functions such as abs, absolute, clamp max, clamp minimum, and rate. Rate we have already checked here. So let's move here. But it says abs mean return the absolute value for each element in vector. If the data point of the time series fluctuate between positive and negative value, you can apply the abs function to display each data point as an absolute value and it will remove the minus one. But it's for clamp max, it return the value but replace them with the maximum value. Let's take an example that we create one expression and that value is goes beyond 100. We know that after 500 I don't require that value, so we can use at that time we can use clamp max 100. This is the syntax that we can use here. Let me execute for you. If I remove here clamp max node CPU second 100, not showing me more than 100, so it shows me here. If I remove this max clamp and remove this one, now you can see here that the values are more, but I don't want to see more than 100, then I can use clamp max. And what my clamp minimum says, it return value but replace them with the minimum value if they exceed that value. Let's use clamp minimum and 10. Clamp minimum comma 10. Now I see that the minimum value it shows 10 here. If I remove here, let me copy this expression here and then go back here. We have some 0, 0.1 and zero point 0.2. So it remove and convert into 10. IRQ, you see one IRQ here. Let me paste it over here. Now IRQ is showing 10. This function will put the value 10 if it's less than 10. I hope it is clear now. And rate we have already checked how we can check the average rate. We can use 2 here. Now move forward here. Lab query and function. We have already did the lab for for this. Now this video we have covered metrics, labels and query and functions. If you have any question, do let me know in the comment section. I will try my best to answer your question. If you like this video, please like and share with your friends and colleagues. And if you want to help me, you can also donate in YouTube method. Bye bye. Thank you. Namaste.